Hello Internet, welcome back to our asteroid belt shader. In this video we are going to be making our planet cast a shadow onto our asteroid ring. This is what we have right now, and as you can see we do have shadows being cast onto the planet. We're using a custom planet ring shadow caster that we actually built in the last video. The issue is that our actual ring itself is not receiving shadows from our planet. And that's sort of one of the key components of planet rings, is that the shadow goes onto the rings. That just makes it look like there's actually something there. Unfortunately, with transparent shaders, you kind of lose that capability. The shadows don't really work that well with this. So what we're going to have to do to actually get shadows back is we're going to have to write our own lighting model. And so that's what we're going to be doing in this video. And it's not something I'm super familiar with, so I actually have a few documentation things we're going to do to actually read up on this, and then I believe we can actually kind of fake casting this shadow onto here, and we can do that using a dot product. At least that's currently the plan, and that should give us a nice sphere that we can cast onto here. So hopefully that'll work as long as our planets are spheres. If we start doing like weird shapes or something, or give them really big mountains, those won't show up in our shadows. But the advantage is this will actually be super fast, and we can tweak it pretty easily. And it can even make our sun appear as if it has like a width or something. So we can kind of affect things that way. At least that's the idea. We'll see how well that works. So this is the shader we have right now. There's nothing really fancy going on here. It's just building our ring. What we need to do is we need to look at, I've pulled up 3 documentation things from Unity and 1 answer in order to get local position, which is going to be used for our dot product. So what we need is, this is just a really basic surface shader thing. I'll have all 3 of these in the description. But this documentation specifically is about how to get specific information into your shader. For example, if we need the world position, this is how you do it. You just take this world pose here, and you drag it into this input. This is actually where we got it from the previous video, and we've already done that, so that's fine. We don't need that, and I don't think there's anything else we need here. I just kind of wanted to point this out because it's super helpful. There's a lot of other documentation here, like if you want something to cast shadows like we've done in the past. The alpha transparency that we used for this shader, and for the last one, that's there as well. So this is a good starting point if you're starting with surface shaders, and it's maintained and written by Unity, so it's usually up to date. This is some lighting examples. So if you look into our surface shader code, there's this standard keyword. It's not really a keyword. There's a standard word here. And so this doesn't really make much sense why it's here. But the reason it is because that's actually saying what lighting model to use. We're saying let's use our standard lighting model on the shader, and this is actually the function. So this is the function that we want to use for lighting. It's built into Unity. There's a few others. There's like Lambert, and I believe that yeah. So there's a Lambert shader, which is going to be different, and then I believe there's a Blinn Phong as well. Nope. Well, actually, yes, but it's expecting different arguments. We're not going to use either of those. We are going to use something we're going to probably pull from here. So there's a diffuse lighting, which is going to be just the Lambert that we were just talking about. That's default and built into Unity. There's another simple Lambert shader or lighting model that they're talking about. There's the diffuse wrap. There's the tune ramp, which is going to do some more tune shading style stuff that you can see here. And then there's the simple specular, which is going to do specular mapping, which is going to have this power function here to get you a specular highlight. And so the specular bits are going to be like right on the cheek, upper cheek there, right below the nose, those kind of highlights. That's what you get with specular color. It's a big ramp up when you get direct contact. Like if light would bounce off of something and go into the light, it kind of helps bring that out. The other thing they have is this custom global illumination, which I was thinking was pretty interesting. I have never used this before, and I'm kind of tempted to try. I'm really tempted to try. So we might start here and see if that blows up in our face. And if it does, we can kind of go back up. It doesn't, actually. Screw it, let's just do it. So I'll just copy and paste, because all the good programmers do that, right? So where does it want this? It's putting it underneath our pragma. So we should be able to just drop it right above this input. Right there. So this is going to be our standard default global illumination. And then we just need to include our lighting. So if you've used C++ before, there's include files, or there's header files you need to include. It's the same thing with shaders. Here, there's just a different extension. So here we need to include Unity's lighting headers, I guess is the best way to say it. So you can just do that. And then the final bit is we need to actually swap out that standard that we had for standard default GI. And now standard default GI is right there. And the only difference is the function actually starts with lighting instead of this. But everything else should match up. And so depending on what you actually pass, or what kind of lighting you're trying to do, these arguments are going to be a little bit different. Since we're doing a global illumination, we should just be able to pull this in. And I might totally screw this up, but we should be able to pull this in and compile, and it should work. Ish? No? Lighting standard default GI not found. Interesting. Oh, that's because I copied the wrong thing. Standard default GI is what we wanted to bring in, not lighting. Like I was saying, you don't want that. So this, assuming I did this correctly, should look exactly the same. But the cool thing is that the value that's being returned from here is actually our lighting value. So if I instead return, let's see, a float 4, or a half 4 actually, of 0.5, 0.5, 0.5, and 0.5, that should get us flat lighting. Yeah. And so we just get this flat monstrosity, which looks awful, but it's a thing. So that's where our lighting is coming from. And it looks like what happens is, I believe, our surface shader actually passes the output into this lighting, or the standard default lighting, and then from that we actually get our color. So after our surface shader has run, after we've actually generated that, we're going to then run it through here and then return the result. And then this lighting standard is actually a Unity function. I might be making that up, but I'm pretty sure this is a Unity function. I'd go to it, but unfortunately that function doesn't work. So we'd have to actually go and inspect this, which you can actually find in Unity's data folder or something, but that's a lot more work than we need to do. All we need to know is that that works. And so I'm going to actually save the result here as our lighting, like so. And then what we need to do is we need to do a dot product. And so the reason we're going to do a dot product is because it detects the direction of vectors. Not so much the direction, but it detects if two vectors are parallel, it will return the length of the vector. If they're opposite, it will return the negative length of the vector, and if they're perpendicular, it will return 0. And so with that, you actually can get like a full circle-ish around your entire thing. But the important thing is that if you look at that, the results of that, you actually get a circle at some cutoff point. And so I'm thinking we can use that cutoff, or that a point in that circle, in that function, and just color everything beyond that black. And so if we get the direction of our light hitting our hitting our model, we should be able to take that and actually derive where things are coming from. The one thing I didn't think about is this requires that we actually know where our light is. And I didn't plug that in. I believe there's a way to get it, but I don't remember it. And it wasn't in that documentation I showed you. Usually in the lighting model, if I remember correctly, some of these other ones are going to have, the light direction, which we could use to get this. Unfortunately, the global illumination is not going to have it, unless I am very much mistaken, and I don't think I am. And so because of that, I think we need to figure out the light. Actually, one sec, let me go pull up that included file, and let's see what's in there, because I think we may be able to find this Unity GI structure, and that may have what we need in it. So I'll be right back. I'm going to pull that up. All right, so I didn't find it. I checked here, the Unity Global Illumination. I checked the Unity physically based shader lighting. If you're wondering where these are, they are here. They're in your CG includes inside of your Unity install under your editor data CG includes. That's where that file, or all of these include files are. So you can kind of look through these to kind of find what you're looking for. I do think I found something we can use. So there's this world space light position. And so my thought is if we know the world position of our object, not our fragment, but our object, we can calculate two vectors, one between our fragment position in world space and the light, and one between our object position and the light, and then compare those two, and that should be enough to get us our dot product. But that's assuming this value works. So I'm going to just copy this over to our planet ring shader. And so we should just be able to drop it in. I believe that'll work. We don't actually need to reference it. We can just do something like that. So we've got the world space light position, and we want to use our input, which we can't use right now because that's not being passed in. I may have gotten a little bit beyond where I wanted to be, because we need our world position, which I don't know how to get here. View direction, light direction. Those are all interesting, but none of them tell me where I am. And so we need to know where we are, because that's how we're doing this calculation. Without that, we're kind of stuck. So they're using like a normal. That'll get them directional lighting, but we can't do point-based lighting. So I may need to do more research, so the next step is we need to get our world position into the shader, and we have our world position, but it's an input here, and it's not being passed down our pipeline into our lighting, because what's getting passed into our lighting is going to be this surface shader output, which is going to be like our albedo how metallic our thing is, the alpha transparency, things like that. We don't get any of these input values. None of those are going to come along. And so we need to figure out a way to get that into here. And I think maybe this will do what we need, but I don't think so. We need to somehow modify this. And even if we use other lighting models, we're still going to need to know the world position. Without that, we're stuck. So I'm going to figure out how to do that, and then I'll be right back, and we can continue on with this. I'm pretty sure, though, this world space light position, I think that's good. That should be able to stay, and we should be able to move forward with that. But I'll find what we need and be right back. I think I've got it. So I don't think there's a way to get the world position into our lighting, but we can fake it. So what I decided to do, probably not the best idea, is we're actually going to use the occlusion value from our shader, or from our output here, as the amount of occlusion that's happening, the amount of shadows we want to do. So theoretically, if this is 1, we're going to use, it's going to be effectively a scalar. So if it's 0, that means we want that to be completely dark in our lighting. So if we look at this, we can do pretty much our lighting times equal to our output dot occlusion. And so if there's occlusion happening, it should cause some shadows to happen. And if not, then it will just do its normal thing. And then we just need to do the calculations in here in our surface shader. And that should eventually propagate down to our lighting. And that should all work out. So right now I'm just setting the occlusion to 1. So it should just be normal. If I set it to, say, 0.5, it should get darker because everything's kind of half shaded. Why can't I move? There we go. So I can move my camera. And you can see we still get some specular lighting there, but it should be darker. And then if I make it totally black, everything's gone. Our specular lighting is gone as well. And yeah, so I think this will do what we need. And if I'm correct, it doesn't appear to be occluding the stars, which is concerning, because so there's still something here. Just because we can't see it necessarily doesn't mean it's not there. So I think we can actually fix that quick. I've got some quick skyboxes. Let's bring in just a red one. Yeah, so this is actually broken. So if it's 0, we actually want it to still draw. We just don't want it to be lit. And that's not what's happening here. So can I multiply the RGB values only? Yes. Okay, so now we're properly getting shading. And so this is a fully shaded ring. It actually looks super sweet against that red background. Kind of like that a lot. But what we can do now is we can actually make this work everywhere. And theoretically, since we're using the global illumination thing, if I add this back and do the lighting, it should receive some of the illumination from our skybox, because it's using global illumination, which means all of the light in the scene kind of bounces around. And so instead of just having this one light here casting light, that light is cast, but then it bounces off of everything. So everything that you see is actually giving off a little bit of light. So in this case, like our skybox is super bright, which is why our planet, even the dark side of it, is red. And you can see it actually kind of adjusts depending on where we are. So even though this whole side would normally be black, some sides have like black back there. And so that's darker than if we go over here, which would still be black, but there's red back there. So the global illumination is actually lighting that. And that's why our ring, which was normally just like blue and pink and greenish teal. Now it's a little bit red tinted, especially in this purple area. And so that's all coming from our global illumination, which is cool. It means it's working. So what we need to do now is we need to actually take advantage of this occlusion and calculate that. So we're going to need two vectors for that. Like we were talking about, we need a difference between the world space light position 0 and our input.world position. So this will be light to point. I'm just going to call that light to point, and then this one will be our light to object, which is going to go to the object's origin, which in our case is going to be right in here, right inside of the planet, right at the center of our ring, which should be ideally right where we want it. So we should be able to do the world space light position 0, like so. That should fix incompatible types in initialization. Uh-oh. Dot XYZ. Oh, float 3 has to be a float 3, otherwise it won't work. There we go. Not throwing any errors, so that variable will work. So that's good. My guesses are paying off. So now all we need to do is actually be able to find the position of our object in 3D space. For right now, I'm just going to subtract off the 0 vector because right now our planet is totally centered in the world. It's at 0, 0, 0, so this will actually work for now, and then we can fix it later. And then what I'm going to do is calculate a dot product. So first off, we want to do these light to point, and we want to normalize each of them. So we want normalize light to point, and we want to normalize the light to object. Because all we want is direction, we do not care about the length of the vector, because this is space, and those are going to be super long, and it doesn't particularly matter either way. Ooh, too much data. I typed float instead of float 3. So this isn't going to change anything, but now everything should be compiling and looking good. So now we have two normalized vectors, and I think the best way to do this is just plug them into a dot product and light to object. This is going to be between -1 and 1 because they're normalized vectors, so the maximum value they can do is the length of the vector. And that's going to be 1 in this case, which is good. So it can be between 1, -1, but we don't want that -1. We just want it between 0 and 1. So we're going to stick a clamp on this between 0 and 1. I don't know if that's actually a function. It is. Cool. And so this is sort of the shading we're going for. It's backwards, but if I rotate this light, we should see it actually adapt to the light, so it actually moves with the light, which is cool. So everything's actually working. I like it when things actually work. That means I'm not being a goof. So we need to switch those, and that's really easy. All you have to do is move one to where the other one was. And that should... No, that won't do it. Never mind. That's incorrect. All you have to do is put a negative sign in front. And that'll switch them. And then the only difference, the only other thing we need is a clamp. So what I think we can do is actually add something on, like 0.5. And yeah, so as we increase that, it kind of pulls it back in. And so I'm going to make this into a parameter we can pass in. So this is going to be our light width. Sure. That's a good enough name for now. So our light width is going to be passed in here. Oh, let's actually call it the planet size. Sure. And that can be between 0 and 1. Yeah, I don't think it makes sense for it to be any bigger than that. Because if it's bigger than that, the light will start like bending around back towards us, which doesn't make any sense. So by default, we're just going to set it to like 0.9. We'll have to play with these numbers because this is going to be wrong initially, but that can be fixed. So we have the light width going in. Cool. And so that looks fairly good. We're getting shadows behind our planet, and there should be no specularity on them either. So they shouldn't shine or anything like that. We're actually getting shadows, which is exactly what we want. And so now what we should be able to do is as I point the light down, that dot product is actually going to be somewhere in the center here, which means it's actually nothing's going to be shadowed, or there's not going to be a shadow anywhere. And then as we move that, it starts shading everything. And actually, when we went underneath it, okay, so that's kind of wrong, but so it only works for positive light values. That's annoying and confusing. Actually, I wasn't expecting that. I wonder if it's seeing the normal from our light and getting confused. So as we go down here, the normals here are still pointing up, even though it's a two-sided mesh. There's only one normal here, and those are going to be pointing straight up. And so if our lighting is based off of those normals to get the proper lighting, it's not going to work when the light is below us. So we should fix that as well, because that isn't correct. But we can do that. So how can we do that? We have the view direction, which is that way. How would we fix this? Because it should work. I may need to actually think on that, like sleep on it, think on it, because I don't necessarily know how to fix that. I'll have to think about that, and we may do another video to resolve that issue, because off the top of my head, I don't know how to fix it, but it does work as long as your light is above it. Doesn't work so well if it's below, which we'll have to deal with later. But so we do have shadows, and theoretically it's casting a actual circle. So if I do something silly, like make this very big, we should be able to actually pull this in now, because that is huge. And then we can actually increase this planet's, or decrease this planet size, all the way up like that. And now we're running into a different problem, and that's our planet shadows are soft because we're interpreting or interpolating between them. So there's going to be some smoothness happening, and we don't necessarily want that. So we are going to need a light scale. These are starting to get even worse. We'll just do a float here. That should be fine. And we'll set it equal to 5? Sure. So what this is going to do is that this is going to multiply the resulting dot product, and then our clamp is going to clamp it. So if we multiply by 4, that smoothness will only happen over a quarter of where it would normally happen. So if we plug that in like that, there we go. So we get much less smooth. And I can actually increase this quite a bit. So if we increase that to like 200, it becomes more or less a solid line going across like that. And then our issue is that sort of took away everything that we needed because we put this in the wrong spot. So we need to do our light width calculation first, like that, and then multiply this. And that will actually get our shader positioned and then scale it, I think. Yeah. And so we can do something like this, and we actually get our light to kind of bleed across our rings. And you can see we're finally getting the effect I was going for, which is a circle. It's hard to tell because of how finicky this is, but we're actually getting a circle cast onto it. Currently, it's not the right size of circle, but you kind of, based on this light scale, we're actually able to determine how precise that circle is. And then with the planet's size, we should be able to fine tune that to get it close to a actual circle. So something like that-ish. So I think there's a lot of fine tuning that needs to go on here, but I think it gets us close. We may need to reconsider the algorithm a bit, simply because instead of going out like it's doing right now, we actually want it to go in. And that may sound a little bit weird, but the sun is bigger than the planet. It's a lot bigger than the planet. And so what that actually ends up doing is those lines are currently going out because we have a single point and we're radiating out from there. We don't want that to happen. We actually want a giant circle, and we're casting over a smaller circle. And so we need to figure out how to solve that somehow. Because right now, since we're casting from a single point and we're going around a circle, we're creating this cone, and that's causing it to go out instead of creating a cone in the opposite direction. So that's on our chopping block. But for right now, we actually do have shadows being cast. We implemented a lighting model, and it does have global illumination, or it should. So I think that's pretty neat. One thing we are missing because of the way we're scaling this is we're actually losing the global illumination along this darkened path. And I don't know how to fix that immediately off the top of my head, but we'll have to think about that. So there's more to do here, but it's a pretty interesting, I don't know, it's a pretty cool looking shader now. We've got planet rings. Granted, it still looks like planet rings from the planet of shrooms, but it's planet rings, and that's a step forward, I guess. And we've got a lot of cool shadows going on, which I like shadows. Shadows are cool. So the next step, I think, is probably to fix that. And then I also want to, right now we have a shadow ring and a planet ring. I don't like that. I want to kind of bring both of those together, especially because that way it will allow us to merge how we're calculating this. So right now, these two shaders have to be exact, and they have to be scaled exactly. Otherwise, we don't get the same effect we're going for. So I want to kind of merge those into two separate passes inside the same shader. So that may be something we'll talk about later as well. But for now, this is what we have. So I guess that's what we'll stick with. So if there's anything you guys want to see, let me know in the comments. I'd love to see it. If there's any other feedback you want to give, anything you think I should improve, let me know about that as well, because I would love to hear that as well. It helps me make what I'm doing more fun and better, hopefully, and hopefully helps you guys better as well. So don't be shy and say hi or say do something better. I don't really, it's up to you. But that's it for now. So until next time, see you, Internet.